So in this video, we're going to be looking at solving systems of equation using elimination. All right, so jumping into our first question, we're asked to solve 2x plus 3y is equal to 15 and x minus 3y is equal to 3. We're asked to find the intersection point of these two functions. All right, so essentially what elimination is, we're trying to, as the name suggests, trying to eliminate variables so we can find one of the variables either by eliminating x we can find y, or by eliminating y we can find x, which we can substitute back into either our first or second function and find our other variable. So our first question, see a plus 2x plus 3y is equal to 15, x minus 3 is equal to 3. And now this is a good case for us to eliminate our y because we have a plus 3y and a minus 3y. So if I add both of these functions, I have 2x plus x, which gives me 3x. I have positive 3y minus 3y, which gives me 0. And I have 15 plus 3, which gives me 18. So this is essentially how you would eliminate one of your variable. Now if you see, I've completely eliminated my y variable and I'm only left with my x variable, which should be easy to solve for now. Just some simple linear equations, divide both sides by 3. Divide both sides by 3. This is x. 18 divided by 3 gives me 6. So x is equal to 6. Now I have to find my y variable as well. To do so, I can substitute x is equal to 6 back into my function. X minus 3y is equal to 3. X is equal to 6, so I have 6 minus 3y is equal to 3. Negative 3y is equal to, I bring my 6 to the other side, so I have 3 minus 6, I have negative 3. Now if I divide both sides with negative 3, to isolate my y, I have y is equal to negative 3 divided by negative 3 is positive 1. So my coordinate of my intersection point is 6 and 1. There we go. Alright, so our second question is a little more complicated, but we're going to use the same method, elimination. We're trying to isolate and eliminate either one of our variables. So in this case, because we have an x squared, x, a y variable, I'm going to try and isolate both my x's, including my x squared and my x. So to do so, I need both my x squared to look the same. So I need 6x squared here, 6x squared here. I want a negative 3x here, I want a negative 3x here. To do so, or 3x rather, so I can times everything. Okay, times my second function with 3, which I would multiply each of my terms with using distributive property. So I would have 6 plus 3x is equal to 3y minus 2. I'm doing this in an attempt to be able to isolate and eliminate one of my variables. So now I'm just writing down my first function back in. 6x squared minus 3x is equal to 2y minus 5. Now that I'm here, I see that I can now I see that I have a plus 3x and a minus 3x, which I can of course get rid of at this stage. So now this would be 0. But add both of these together. So I have 12x squared plus 0 is equal to 5y minus 17. Okay, I don't think this works out this way. So let's try and eliminate our our x. Let's try and eliminate our y variable in this case, because I think that would work out much more easier and look much more uh, better and more organized. So to isolate my y variable, I can times my second function with a 2. So wait, I'm just gonna write my first function down. So 2 times 2 x squared gives me 4 squared. 2 times x gives me plus 2x. 2 times y gives me 2y. Negative 4 times gives me negative 8. Now to get my y variable out of this, to eliminate my y variable, I can times my second function with a negative. So I'll be left with 6x squared minus 3x is equal to 2y minus 5, negative 4x squared, negative 2x, negative 2y plus 8. My reason I did that was so I can have a negative 2y here. So when I add both my functions together, or both my equations together, I get 6x squared minus 4x squared, sorry, gives me 2x squared. Negative 3x minus 2x gives me negative 5x, plus 2y minus 2y is 0, negative 5 plus 8 gives me 3. Alright, now let me write this down again. 2x squared minus 5x is equal to positive 3. I can take my positive 3 to the other side, so I have 2x squared plus 5x. My is equal to 0. Now I can actually factor this to get my two possible x values. So factoring nice and easy. Plus 3 minus 1, I have x is equal to 1 over 2. And then 3, I do this by equaling each term to 0. So I would 2x minus 1 is equal to 0, I would solve for x. X plus 3 is equal to 0, solve for x. So x is equal to negative 3. X is equal to 1 over 2. There we go. So those are my answers right there for my x coordinate, but I also have to find my y coordinate. So what I would do here is I would so I would plug my x values back into one of my functions. Let's see. I'm going to plug it back into 2x squared plus x. So my second function. So that should be 2x squared plus x is equal to y. 4. So I'm going to plug in x is equal to 1 over 2 and x is equal to negative 3. We're going to start with x is equal to 1 over 2. So 2 times 1 over 2 squared plus 1 over 2 is equal to y. I can square my 1 over 2. 1 over 2 times 1 over 2 is 1 over 4. Plus 1 over 2, that stays the same, is equal to y minus 4. 2, 2, 2 divided by 2 is 1. 4 divided by 2 gives me 2, so 1 over 2 plus 1 over 2 equal to y minus 4. 1 over 2 plus 1 over 2 gives me, I add my numerators, 2, my denominator stays the same. Cancel 1, 1, 1 is equal to y minus 4. Take my 4 to the other side. So I have 1 plus 4 is equal to y, and I have y is equal to 5. So my coordinate now is, one of my intersection points at least, is 1 over 2 and 5. So I know that. 1 over 2 comma 5. There we go. For my second intersection point, I would do the very same thing, except I would substitute x is equal to negative 3 into my 2x squared plus x is equal to y minus 4. Perfect. Make sure I've copied that correctly. Yep. So now I substitute x is equal to negative 3 into this. So I have 2 times negative 3 squared minus 3 is equal to y minus 4. I know negative 3 squared gives me positive 9. Minus 3 is equal to y minus 4. 9 times 2 is 18. Minus 3 is equal to y minus 4. 18 minus 3 gives me 15 is equal to y minus 4. Take my y to my other side. I have 15 plus 4 is equal to y. Hence y is equal to 19. So there I have my second intersection point. Negative 3 and 19. There we go. So that was that question. I'm going to leave you guys with another question which you can do on your own. It's x squared plus y is equal to 8x plus 19 and x squared minus y is equal to 7x minus 11. So that was solving systems of equations using elimination method. Hope this video helped.